We are dealing with complex numbers and imaginary numbers. I'll explain the purpose of that. First off, a complex number is any number that can be written as a plus bi. A and b are real numbers and I is imaginary. Today a is going to be 0, so you're just going to have a single term. Okay, we're just simplifying. We're starting out very basic today. The bi term is considered an imaginary unit. The imaginary unit I is a complex number whose square is -1. I'll explain that further in a minute. Imaginary numbers. Sometimes quadratic equations do not have real solutions. So for instance, when I just went over the homework, that one where it had the square root of a -3 that had no solutions, it has no real solutions, but it has 2 imaginary solutions. We just haven't gotten there yet. Okay, so for example, if we were solving x squared plus 1, that one's not factorable, it's considered prime, but it does have 2 imaginary solutions. Imaginary will result from the square root of a negative number. Okay, so this is where these come from. Now some of you may be thinking, what's the point of imaginary numbers? If you do anything in the future in the field of electronics, imaginary numbers are used all the time. If you go into anything that is under the umbrella of a science field, you will use this. There are other things, those are just off the top of my head. Some of you, imaginaries will be limited to your math experience in high school, so it's going to vary. Okay, they are not overly complicated. Once you get the hang of it, you'll just be moving through, but it's going to take a little bit. Okay, but by the end of today, it should make a lot more sense than it is right now. Now, make sure you take good notes as always. I'm going to add to this chart on the right side, so just be aware of that. It will make your life easier if you write down the same thing. Now, this is expanded. These are how the rules work. We will work with them. Okay, so be aware of that. So the imaginary unit of I is a result of the square root of -1. Okay, so you'll be simplifying radicals in a second. They will be down there. Anytime there's a negative, an I is going to be in your answer. Okay, so I is a result of the square root of -1. Okay, so the square root of -1 equals I. That is probably the most encompassing, all-important one. Okay, that and this next one, but we will use the others further. Now I squared, if I expanded that, that would be an I times an I. Okay, and yes, the I's are a little bit curved just so they don't look like ones by accident. Okay. Now if both I's are rad -1s, okay, that would technically be a rad -1 squared. The radical and the square would cancel each other out, leaving the -1. So that is just why it is the way it is. Okay. So I squared is -1. You will use these two things the most often, especially tomorrow. For today, we're going to use a mix of all of these. Okay. Now, I to the third power, that's 3 of them. Okay. Or it is I to the second and I to the first, so you can add the exponents together. So that would be a -1 times an I, which is a -I. Okay. If you want to see the expanded result, just look through that. Okay. This column that I'm writing over here is all you really need to know. Okay, but these are why they are the way they are, instead of me just telling you. Okay. It should not make sense yet. I'm not expecting it to. Okay. If you're looking at me like I have 3 heads, that's normal. Okay. I to the 4th is 2I squareds. Okay. Since I squared is -1, -1 times -1 is +1. So that is why I to the 4th is equal to a +1. I to the 5th, you can break apart in several different ways. That could be an I to the 3rd and an I to the 2nd. Just split apart. Okay. So that would be a +I. So I to the 5th is a +I. I to the 6th is technically 3I squareds. So it's a -1 times a -1 times a -1, which is a -1 again. I to the 7th, you can break it apart several different ways. If you did I to the squared times I to the 5th, so as long as the exponents add up, you can split it however you want to. We could have done the 3 and the 4, but it would give you a -I. Now I want to point out something. Starting with I squared. It goes -1, -I, +1, +I. Then it starts over. -1, -I. What would the next two be? +1, +I. Okay. Now you're going to use this chart to help you. Okay. And we're going to use it towards the bottom of this paper. So we're going to use these to solve square roots. Okay. So this column right here is a shorter version of this for you to memorize. But there's going to be easier ways to work with them. Okay. So we're going to refer back to that as needed. All right. So be patient if you're not 100% with me so far. We're going to start off by simplifying square roots. Now we did this with positive square roots. We do the exact same thing. Now since it's a negative number, these would indicate imaginary solutions, so there should be an I in your answer if it's negative. That's the only thing that changes. Because this is equivalent to -1 times 18, correct? This is the same thing as that. Okay. Now what does the 18 break into that we did 2 weeks ago? Less than that, actually. 9 times 2 or 6 times 3. But I want you to break it down completely. So we would have a -1 still. The 18 breaks into a 2 and 2 3s. It's either 6 times 3 or a 2 times 9. Bring out any pairs. So what pairs do we have? A pair of 3s. Now that's going to come out just like before. Okay. Now the only other thing that comes out, because there's no other pairs, but the square root of -1 is what from your chart? It's just I. Now anytime you have a negative, that's automatically an I coming out. Just one. Okay. So anytime you see the square root of a negative, anything, an I comes out. And you'll just put the I after the 3. And then we just have a rad 2 left. Only thing that's different is you have an I now for these. Okay. Square root of -1 is an I. Okay, meaning an imaginary unit. Okay. Similarly on this one, we're going to break this one down completely. Okay. That is suddenly a -1 times a 125. Okay. What's 125 completely broken down?
5 times 5 times 5.
Okay, it would be 5 times 25, which is 3 5s total. And then x to the 5th means 5 x's. If you remember the shortcut I gave you about a week and a half ago, you may use it, where if it's an odd exponent, just take one of them out and then divide the other power by 2. Or you have to expand the whole thing. So what pairs are coming out? A 5. 2 x's. Okay. Anything else? The square root of -1 is an I. So that one also comes out. It's kind of its own little thing. So on the outside, we have a 5, we have an x squared, and we have an I. Now you can put the I after your variables, or you can do 5ix squared. I don't care. Put the I first, or sorry, put the 5 first. Then the order of the others don't matter. What's underneath the radical sign still? A 5 and an x. The only thing that's changed there is you have the square root of a negative, which just means an I comes out with whatever you bring out. Okay. Sometimes an I is the only thing that comes out. Okay. Not too bad so far. Okay. So we're gonna refer for these next 3. We're gonna refer back to the chart up here. Okay. Because if you notice, they are bigger exponents. So we are going to simplify these. Bless you. Now these are going to be one of those 4 things in your chart. It's going to be a positive one, it's going to be a negative one, it's going to be a positive I or a negative I. Okay. Now we're going to split these apart because there's obviously no I to the 12th up there. And there's no I to the 13th, there's no I to the 45th. Okay. So we're going to break these down into ones that are in the chart. Okay. So for example, 12 can break into an I to the 6th and another I to the 6th. Because 6 plus 6 would be 12. Hopefully you remember your exponent rules from Algebra 1, 2. But this would be equivalent to I to the 6th times I to the 6th. As long as the exponents add up together, it's the same thing. Now you could have done it into a 5 and a 7 if you want to. I would actually recommend the even ones. Makes it a little bit easier. There's less I's that way. Okay. Now I to the 6th is what from your chart? negative 1. So a negative 1 will replace every I to the 6th. And we have 2 of them. Okay. So simplifying these down, this would be equivalent to negative 1 times negative 1, which is what? What's your answer? Okay. Your answers for all of these with an I to an exponent is either an I, a negative I, a positive 1, or a negative 1. Okay. One of those 4. Okay. Now 13 you can split up multiple different ways. Anyone have an idea? 7 and 6. Okay. Doesn't matter the order. So I'll do I to the 6th times I to the 7th. Okay. I to the 6th we already used, so that's a negative 1. Okay. What's I to the 7th from your chart? It's a negative I. You can write a negative 1I if you want. That 1 is there either way. Okay. Now, some of these you may have a lot of different negative signs. An even number of negative signs results in a positive. If there's an odd number of negative signs, it stays negative. So since we have 2 negative signs, here we had 2 negative signs that resulted in a positive. 2 negative signs would be a positive, what? It would be a positive I, or a positive 1I. It's up to you if you want the 1. Okay. Now these we were able to split into 2 pieces. Can we do that with 45? No. Okay. Now you have a few options here. You can do you can do I to the 5th 9 times. However, that's not a 1 or a negative 1. I would stick with more of the evens if you want to. Now 6 does not go evenly into 45, but it takes up majority of it. How many times does 6 go into 45? 6 times 7 would be 42. How many are left over? 3. So we can do 7 I to the 6th and then an I to the 3rd. Okay, that's an option. You do not have to do it like that, but if you keep more even powers in, those are either 1s or negative 1s. So it makes it a little bit simpler. So yes, write out 7 I to the 6th, 2, 3, 4, 5, 6, 7. So this will give you 42, and then 3 more. Now this is shortcuts to you writing out rad of negative 1 squared, rad of negative 1 squared, rad of negative 1 squared, all the way down. Okay. Now each I to the 6th is what? Negative 1, and what's I to the 3rd? From your chart. Negative I. So we have 7 negative 1s. 7, and then we have a negative I. Again, all of these answers with the larger exponent should either be a 1, a negative 1, a positive I, or a negative I. What's this one? There's an I there, so there's definitely an I involved. Is it a positive or negative? How many negative signs do you have? 8. Eight's an even number, right? Okay, so an even number of negative signs means the result is a positive. Okay. I. Okay. So it had the same answer as this one, but it depends on what you have. Okay. Now, you may get I to the 200 something power. Technically, you could do it like this, but would it take a little bit? Okay. Now this is a shortcut to the chart up here. There's a shortcut to this. But I need you to understand where these were coming from first. So is there any questions before I show you that? Okay, so on the back. So in example C up here, we had I to the 12th. Okay, so shortcut to finding larger exponents. So we already know the answer is 1 from example C. So we did it this way first. So we had I to the 12th, we split it into I to the 6th, I to the 6th. That would be a negative 1 times a negative 1, which is a positive 1. Your alternative to that, which you now have permission to use. Okay. If you notice down here, the exponent on I is 257. That would take a while. Okay. You could still do it, but it would take longer. So your other alternative to this, you divide whatever the exponent is by 2. Now it's either going to result in a whole number or it's going to result in a something and a half. Okay, so based on what you get, so for this one, 12 divided by 2 is 6. Because 6 is an even number, if the bigger number, so this is just 6, if it was 6 and a half, this would be different. But if the big number is even, that would indicate a positive 1. Now there's no remainder, there's no fraction, there's no decimal, which would indicate no I. Okay. Now I'll demonstrate this on the rest of it. But the rules for your shortcut are right here. You divide the exponent by 2 no matter what. If it's an even number with no remainder, meaning no half, the answer is positive 1. If it's an odd number with no remainder, the answer is negative 1. If there's a half or any remainder, you tack an I onto one of those. So it's either a positive I or a negative I. So an even number, odd number. Now we already did I to the 13th on the front the longer way. So we're going to do it the shorter way, which you get the same thing no matter what. Now your calculator is not going to know this type of stuff, so this is going to be a memorization on your part. Okay. You would divide the exponent by 2. Now what's 13 divided by 2? 6.5 or 6.5, whatever way you want to write it. 6 is what type of number? It's an even number, which means a positive 1 comes from that. Any fraction left over, so if you're dividing an odd number by 2, this is going to happen every time. This half or a 0.5 would indicate an I. And then 1 times I would just be I. On the front, we did I to the 13th. We just did it the longer way. Did we get I? Yes, we did. Okay. So either way, the answer is the same. Okay. Now we also did I to the 45th, but that took a little bit. If we divide 45 by 2, what do we get? 22 and a half. 22 is an even number, which would indicate a positive 1. So an even big number is a positive, odd big number is a negative. That's the only difference between the two. So this would give you a 1, this would give you an I, which gives you just I. If you want to write a 1I, that's fine. Either way, it's there. 63 divided by 2. 31 and a half. Now 31 is odd, so what does that mean? That is a negative 1. Okay. The half means an I. Okay. So you can write it as negative 1I or just a negative I. I will leave that up to you. They're both the same thing. Okay. This saves a lot of time. Otherwise you're doing what we just did on the previous 3. Okay. I'll do one more with you, then I want you to do the next 4 on your own. 257 divided by 2. Huh? 120 what? 8. 0.5 or a half. If you like the 0.5 better, that's fine, but that would be considered a remainder. So what's this one? I. It's an even big number, and there's a half left over. Okay. If there's no half, it's just a 1 or a negative 1, depending on if it's even or odd. So try the next 4 on your own. I'll give you a moment to do that. You should get either a positive I, a negative I, a positive 1, or a negative 1. It's one of those 4. Your alternative is to break it into a bunch of I to the 6th or otherwise, which would take a while, depending on how big the number is. Yes. So the answer should be either 1, negative 1, 1I, or negative 1I. What answer are we getting for I to the 105th power? Positive I? Okay, so I heard a positive and a negative. So what's 105 divided by 2? 52 and a half. 52 is an even number, which is no negative, which is positive. The half would be an I. Answer for K. 1. Okay. There's no I because 20 divides by 2 evenly. There's no fraction. There's no decimal. Okay, that's no I. It's either positive 1 or a negative 1. It's positive because 10 is an even number. Okay. What about I to the 14? Negative 1. Because 14 divided by 2 is 7, and 7 is an odd number. Okay. If there's no fraction, there's no I. Okay. And then M? Negative I? 11 divided by 2 would be 5.5. 5 is odd, so that's where the negative comes from. Half is the I. Making a little bit more sense now. Okay. Is that chart on the front confusing? Yes, but that is its most expanded form. So I just need you to understand where it came from before I just threw this at you. Okay. The ones you'll use the most is the square root of negative 1 is I, and I squared is negative 1. Okay. Those are the two we will use the most with operations tomorrow. We do have 3 more problems. Are there any questions before we solve these? Okay. You guys look a little bit calmer than when I first started. Now we're going to solve for x. Now all of these are going to be, if we tried to factor them, it would either be just GCF or unfactorable, depending. But these are going to give you imaginary solutions. Okay. So with these, I don't want you factoring them. I actually just want you to isolate x. So how would you do that on this first one? If I just want x by itself, I'm going to subtract 48, move it over. Okay, so all these are the same 2 steps every time, pretty much. Okay. So you'll have 3x squared equals negative 48. Now what? I'm trying to isolate x, so I'm going to divide by 3. What's negative 48 divided by 3? Negative 16. How do I get the square to go away? Square root both sides. Now up until this point, we could take the square root of a negative number. Now one of the problems I did from 3.8 assignment had there was 1 plus or minus rad negative 3 over 2. That would be no real solutions, but it actually has 2 imaginary solutions. Okay. So we haven't done that to this point, which is why we didn't cover that. So now we have x equals. Now when you take the square root and you're solving, I'll remind you, you need that plus or minus symbol. Okay. So make sure to have it. Now, is 16 by itself a perfect square? Yes. So you can break it down into negative 1, and then it's a pair of 4s or 2 pairs of 2s. Okay. So if there is a perfect square in here, take its root out, which would be 4, and then that square root of a negative 1 just means there's an I tacked on it. Okay. Or you break it down like we did on the front. Like that. Okay. But if you see a negative sign, it's going to be an I, and then pull out any pairs if you can. But if it is a perfect square without the negative, then there won't be any radical left over. So the solutions of these are positive and negative 4i. Okay. Questions there? All right. For O, what do we do first? Subtract 20. Make sure you're adding or subtracting first, unless there's parentheses, but I don't even think you'll get that. Then we would divide by 5. What's negative 20 divided by 5? Negative 4. Then we get rid of the square by taking the square root of both sides. Make sure you have positive and negative results. 2i. So 4 is a perfect square, that's fine. And I just comes out with it from the negative sign. Because again, this is really a negative 1 times 4. So the 4 square root is 2, square root of negative 1 is I. Not too bad. They should be pretty quick. And the last one? Subtract 24. Divide both sides by 4. X squared equals negative 6. Take the square root of both sides. Now, does 6 have any pairs in there? No, just a 2 and a 3. So rad 6 by itself is already simplified, but that negative needs to come out in the form of I. So your answer for this one, since nothing can come out besides the negative, would be plus or minus I rad 6. Okay. So simplify what you can. If you can't, then you leave it, but you should take an I out. Okay. These are the basics today. We're going to do operations, but it combines what we did today with what you've done previously with combining like terms and stuff like that. Okay. Any questions on today's notes at all? Again, this